All right, so to graph a quadratic, highest degree of 2, we have the property of symmetry that's really going to help us. No matter where I move this vertex, if it's a maximum or a minimum, we end up with a symmetrical picture. So our task is really to figure out where is that axis of symmetry and work from there. In our standard form, we have ax squared plus bx plus c. We're going to use those values for x equals the opposite of b over 2a. So it's a pretty simple formula for the axis of symmetry. One thing I would point out, I always say the opposite of and kind of write that negative separate. I find that helps me check it as a final step. Some people like to start with their standard form of the quadratic by writing a equals b equals c equals. So we have a equals 4, b equals 8, c equals 7. That might be an unnecessary step for some of you, but some of you might also really like just having the numbers clear there as a reference. When I go back to the right, I'm working on my axis of symmetry. X is going to equal the opposite of, and I'm leaving myself blanks to fill in. My b value was 8. My a value was 4. So if I start to evaluate, x is going to equal the opposite of 8 over 8. X equals -1 is where my line of symmetry is going to be. So I know if I go back to my graph that my axis of symmetry is over at x equals -1, but I don't know where on this it is. So what I'm going to do is take this value and substitute it into the equation for x. I'm using that quadratic to say, okay, if x as -1 is the input, what's the output? So I'm thinking of y equals 4, -1 squared is 1, so I'm going to leave that alone, plus 8 times -1 is -8, plus 7. Y is going to equal 3, so I'm going to have a vertex at -1, 3. From there, I'm going to pick any other input, and 0 is normally the easiest. I'm going to plug in 0 here. I would have a point at 0, 7, and that's what my parabola should look like.